Here we go, the starting of chapter 8. So one thing we have to know about chapter 8 is the fact that we have this graph right here. Reciprocal family, it means that we have x on the bottom. This is my parent function. My parent function always going to have x on the bottom of the fraction. X can't equal 0 because you can't divide by 0. If you have one thing, you can't give it away 0 times, unless if you're rude and you want to keep it for all to yourself. But that's why we can't have 0 on the bottom of a fraction. So this is what my parent function looks like. We're going to get into what these all mean. One thing we will always have is this a will be a stretch. Remember, if that's negative, it will flip it. So that means this curve would be down here and down here if it was flipped. H will move left and right. K will move up and down. What exactly moves? We'll have to figure that out. So if I'm going to graph this, again, I can put this into my graphing calculator. Y equals, clear that out, 8 divided by x. I'm going to go to my table. Look, I have an error there. And so I can't have 0. Can't have 0 because of the fact that x can't equal 0. Because if you have 0 there, then that would be a no. So if I plot these points right here and then draw this. One thing that's also very important to know, because of the fact that we have this asymptote at x equals 0 right here, because you can't have x equal to 0, we have an asymptote, we have a vertical asymptote. We also have a horizontal asymptote. In each reciprocal function, we will have a horizontal asymptote. That horizontal asymptote in this problem happens to be at y equals 0. The reason why, because there's no number at all that you could plug into here and get 0 out because of this restriction. So this is what typically it looks like. My domain, if I look at this, the only restriction I have, if I look left to right, I still have an arrow pointing to the left, I still have an arrow pointing to the right, but right here, x cannot equal 0. So my domain restriction would be x can't equal 0. It can be anything else but that. My range, when I'm looking at this, I can go down forever. I can also go up forever. But again, I have that asymptote. So y cannot equal 0. My x and y intercept. So x-intercept means where does it cross the x-axis? Well, because we have this horizontal asymptote, that means we will not have an x-intercept. Same thing as a y-intercept. Because of these asymptotes right here, because we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0, there will be no x and y intercepts. Intercepts not available. Now I want you to try to do this B problem by yourself. So because this 10 is like our a, it stretches it out, the parent function out more. It just kind of has a little bit more of a curve right here. My horizontal asymptote is still at y equals 0. My vertical asymptote is still at x equals 0. I still do not have that intercepts because x and y intercept because of the fact of those asymptotes. Now, we have each part of graph as a reciprocal as a branch. This is my parent function, okay? Typically, that we will have stretches and compresses will still be in these two quadrants. This is typically in my parent function, the two quadrants. If for some reason it got flipped, it would be in these two quadrants. So again, the quadrants go 1, 2, 3, 4. So typically it's in 1 and 3. If it got flipped, if it's negative, it would be then 2 and 4. So just kind of going over our transformations, this is my parent function. A will stretch it or compress it. Typically in this case, it will be stretched. If A is negative, it will going to be a reflection over the x-axis. Here, if I move left or right, H always moves left or right. Remember, it's always opposite. That will be my asymptote. This will change, left and right will change my vertical asymptote. Up and down will change my horizontal asymptote. So right now I'm going to put this in my calculator to get my points. So if I go to y equals, I'm going to have 1 divided by, I have to make sure to put this in a parenthesis. Oops, x plus 1. I need the 1 there. In parentheses and then subtract by 2. So I'm going to go to my table. I'm going to figure out what points I'm going to plot. Error is probably going to be that asymptote. Your graph will tell you an error as an asymptote. So at negative 10, I have about negative 2 and a little bit. Because of this, at negative 2, I have negative 3. 1, 2, 3. And then I have an error. Now, if I just go off of those 2 points, it's not very much. At 0, I have negative, at 0, I have negative 1. And if I go to negative, or at 10, I have negative 1 point close to something. I'm going to push graph so I can kind of see what this looks like. Again, there should be 2 curves, but before I actually do the 2 curves, looking at this graph, this right here is going to move it left 1. So left 1 would be right here. So that's going to be my vertical asymptote. Vertical asymptote at x equals negative 1, because this was left front. This is going to move it down 2. So if I have down 2, this will be the line. I would always draw these asymptotes before you actually draw your curve, because if I see that you go past the asymptote, then that would be incorrect. Once you have these two, that's going to kind of show you where the 2 curves could be. So here are my 2 points. I know there should be some sort of curve that looks like this. It should hug your asymptotes. It should hug your asymptotes. I'm not looking for perfection. I'm looking for something that looks decent. Now I can have my x and y intercepts. So I'm dealing with my x-intercept. So x-intercept means that y is equal to 0. So if I set this equation equal to 0, so I'm finding my x-intercept, plug y is equal to 0. That's what x-intercept means, that y is 0. First thing I'm going to do is add over this 2. So I'm going to add 2 over. I'm going to get rid of this division right here. This fraction bar is this division. So I'm going to multiply by this whole thing. So this becomes 2, x plus 1 is equal to 1. Personally, I'm going to distribute that in is equal to 1. I'm going to subtract the 2. The opposite of adding would be subtracting. So that becomes a negative 1. 1 take away 2 would give me a negative 1. And then I'm going to divide by 2, because this is multiplying, so the opposite of multiplying, dividing. So my x-intercept will be at x is negative 1/2, y is 0. So I could actually plot that too. X is negative 1/2. Oh, I kind of actually already have that. That's good. My y-intercept is a little bit easier, because y-intercept means you're plugging 0 in for x. Plugging 0 in for x. So if I were to solve this, 1 over this becomes 1. This becomes 1, take away 2, that would be negative 1. So my y-intercept is going to be 0, negative 1. So again, I should already have that 0, negative 1 spot right there. Also, I'm also asking for asymptotes. So my vertical asymptote will be at x equals negative 1. My horizontal asymptote will be at y equals negative 2. Left 1, down 2. That moves your asymptote. And the last thing I'm looking for is domain and range. It's always going to be based off of your asymptotes. X cannot equal negative 1. In my range, y cannot equal negative 2. It can go all the way left and right, but it can't equal this. It can go all the way down and up, but it can't equal this. Now I want you to try to do B by yourself. It's going to be kind of hard to see here, but here is my x-intercept. I tried to make that in light blue. You can't see that point, but I did plot that point. Here's my y-intercept. And again, I tried to make that in pink. Oops, I forgot that. My asymptotes, I'm moving right 4. So that's this asymptote right here. That's also my domain restriction. X cannot equal 4. I'm moving up 6. So that's my horizontal asymptote. That's my range domain restriction. So your graph should look something like this. I left my answer as fractions. I would suggest that you do it also. This next question, it's already telling us that this was my function, and then somehow it got moved. What is the equation? So if I look at this, first, this is counting by 2s. It's kind of hard to tell here, but this is because it's in between this. So this was 2 and this is 4. So this looks like it at x equals negative 3, there's an asymptote. And this is 1, 2. At y equals 2, there's an asymptote. So if I'm going to write what the new equation is, this is what I already have here. Okay? This moved it to the left 3. Remember, this is the number that moves left and right, 3. Since it's opposite, this would be a plus 3. Here, I moved up 2. The number on the outside moves up 2. I want you to pause the video and try to do the next one by yourself. You should have got moved right 1, so that'd be a subtract 1 with the x, and move down 4, that's in minus 4. This next question is pretty long. Here, it says it costs $750 for to ride a bus. It's asking us to write an equation. So if you want to stop and read the whole thing by yourself, you definitely can do that. It says what function represents the cost of the students? Well, the cost for students would be 750 divided by n, because n is how many people actually are attending. What is the domain? So if I'm thinking about my domain, x has to be in between, well, 1, there has to be at least 1 kid coming. But 57 people can fit on this bus, but 5 of them are chaperones. So there only can be 52. So it can be 1 through 52. Or else we can just do 1 through 52 because it's a word problem. So my domain, my x value, how many people can attend it is this. Same, how many students must ride the bus to take the cost per student is no more than $20. This right here is $20. So how many people have to ride the bus? So if I multiply by this n, 20 times n here, I have 750, divide by 20, and I have n is equal to is 37.5. You can't have 0.5 of a person, so in order for it no more than 20, that means there has to be, the n has to have at least 38 students have to attend in order for it to be $20, or actually a little less than that. I want you to try to do B by yourself. So my model would look something like this. The cost would be the total number, 1,200 divided by number of students that come. The domain has to be in between 1 to 3 and 12 because 13 is chaperones. So how many students have to come in order to have it be $7.50? This next question is saying we have 30 spots that we get a free event. So how would that change it? So if I still have my $7.50, but in this case now, the number of students would be, that would pay, number of students, and 30 of them will not be paying. 30 people of the number of students would not be paying. How many more kids will come? I want you to try to solve this now by yourself. Some of you might have already thought, well, it's still going to be the same as up here, but now you're going to need 30 extra students because those 30 students would not be paying. So we would need 190 total students. What I personally did is I multiplied over and then I divided by the 7.5, and that's where this 160 came from. Instead of distributing, you could have distributed, I chose not to, and then added the 30. There you go, 8.2, not so terrible. Have a great day.